Welcome back. As you may know, may not know, don't know. Maybe you know, maybe you don't know. Who knows? Anyway, on a serious point, I'm working on a series of videos on general equilibrium, specifically with reference to the Edgeworth Box diagram. As you know, general equilibrium is central to um, market economies, etc., etc. So, because it ultimately deals with demand and supply, equilibrium prices, etc., etc. So, it's a central concept, a central theory in economics, specifically in in market-based capitalist economies. So we've done 3 already, and thanks for all the views and support. Seems to go well. And yeah, please continue to watch them and like and subscribe, share the videos. It just helps the channel grow and it helps me stay motivated and to continue building the content. So in our previous, so thank you for that. In our previous video, we ended with this idea of trade moving from a non-general equilibrium position to an equilibrium position through trade, meaning the buying and selling, etc., etc. So we sort of ended up with this position or this illustration. And remember, central to general equilibrium is this idea of, let me just go get there, this idea of the market rate of substitution X for Y for person A must be the same as the marginal rate of substitution X for Y for person B. That is general equilibrium. Okay. And there's a whole lot of things that happens there, efficiency, blah, 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 blah. So there's a whole lot of things that's happening at that specific position. So this video will now focus a little bit on prices. Where does prices fit into this whole thing? Because remember, in here specifically, we're talking about relative prices, meaning the price of Coke for haircut in terms of haircuts and the price of haircuts in terms of Coke. And for each person, A and B, it would be different given their specific endowment, what they trade for, etc., etc. So, okay, so that relative prices is not it's not prices in rands and cents or dollars or euros. It is relative prices. Now, what does that mean? It means that the price of Coke in terms of haircuts, or the price of haircuts in terms of Coke, for person A and B. Okay, so that's specifically what we're gonna talk about. Okay, so the prices of Coke and the prices of haircuts. Now, before we can contextualize prices in terms of the Edgeworth Box diagram and where it fits in here, let's just quickly go and refresh our memory in terms of the budget constraint. Okay, because that's the beginning of the discussion on prices. Okay, so let me quickly draw our trusted y-axis and our trusted x-axis. Remember, it's in the context of consumer behavior or consumer choice. And remember, a consumer household wants to maximize his or her total utility. Okay. So each household would prefer to be on the furthest indifference curve as possible, meaning the indifference curve furthest from the origin. What stops a household from consuming unlimited is the budget constraint, meaning the amount of money, resources, correct word. The resources available, remember, resources are scarce, money is scarce. So therefore, the budget constraint acts as, it says, a constraint on the consumption of this particular household. It's a constraint on the maximizing of utility for this specific household. It constrains, it keeps you from just consuming and consuming and consuming and consuming. If you walk in the mall, if you had unlimited money, you've seen some of those YouTube videos and things where, the guy or the person gets to the shopping mall and there's somebody says, well, just buy whatever, I'll pay for it. Or here's 2 trolleys, see how much you can pack in a minute or 2 minutes. And they just go ballistic without caring about prices and they just go ballistic. So same with happy hour. In that happy hour, you drink things that normally you wouldn't drink. Buy one, get one free, whatever the case might be, discount, 50% discount, whatever the case might be. Because your budget constraint in that case does not necessarily apply. So without a budget constraint, you will go cuckoos, bananas. You will take whatever you can get, whether you need it, like it, it doesn't matter. You just take. So that's what the budget constraint is. It's constraining, meaning it's limiting your ability to consume, it's limiting your ability to maximizing your utility. So you must maximize your utility within your budget constraint. Okay. So obviously this is the quantity of Y and that's the quantity of X. Okay. And this is 0. So at that point, you don't consume anything. And as you move to the right and to the you start consuming more and more and more of Y and X until you reach a point where you can't consume more because you can't afford it, you can't buy it, etc., etc. Okay, so let's put it in context that the price of Y times the quantity of Y plus the price of X multiply the quantity of X is going to be your budget. It's going to be your budget constraint. Let's call it BS. It's going to be your budget constraint, or it's going to be your total income. Okay. So if the price of Coke, let's say Y is Coke. Did we say Y is Coke? Yes, Y is Coke. Let's say the price of Coke is 10 Rand and you're consuming 6 and the price of a haircut is 5 and you're consuming 2, then your total income is 5 times 6 is 60 plus 5 times 2 is 10 is therefore 70. Okay. So for this person A, his budget constraint is 70. He has 70 Rand, let's for argument's sake. And he's spending that 70 Rand, given the prices of 10 Rand and 2 Rand, he can afford 6 of Y and 2 of X. Okay. So he cannot consume more of both because he simply doesn't have the budget for that. So you can make all sorts of permutations here and play around with the numbers. Point is that at 10 Rand and 2 Rand, he cannot consume more. Now, obviously, it makes sense that if the prices of this increase, then he's going to have to consume less of this, or he will have to consume less of X, either one of the two. So there's a whole lot of, let me just save. There's a whole lot of permutations that we can do. The point is that the 70 raised stands constant. Okay, he can only consume more of both or more of something if the prices of those things decrease. In the absence, ceteris paribus, in the absence of that, income increases. If that income increases, obviously, given the prices, he can consume more. But at 70, he's fixed. He has constraint in this particular terms at 6 Cokes and 2 haircuts at the price of 10 and 5. Okay. So we can plot the budget constraint as a linear function. We can plot it as a linear function. Okay. And obviously this has a slope. It has a constant slope. Okay. And that slope of this budget constraint is the price of X over the price of Y. Now, how do I get to that? How do I derive the slope of the budget constraint as the price of X over price of Y? How do I do that? How do I get to that? Because remember, this is the change in Y over change in X. So that's a general calculation of the slope. It's a change in Y over a change in X. And so in this case, the slope of the budget constraint is also equal to the relative prices of X and Y. Price of X over price of Y. So how do I do that? So remember, that is quantity. Right? And that's quantity. So what happens at this specific point? What happens there? The quantity of X is equal to 0. And what happens at this point? That point. The quantity of Y is equal to 0. Okay. Because you're on the axis. And so at this point, I said, you have only Y, you have 0 X's. And at that point, you have only X and 0 Y. So at that point, X is 0, quantity of X, and that point, Y is 0. So we can put it in our equation to calculate mathematically that point. So that point, as remember, your Y is 0. So at that point, Px over Qx is equal to your full budget constraint. Okay? At that point, your Px times Q is equal to your budget constraint because, remember, Y is 0. So that whole thing becomes 0. So you only have that. And at this point, okay, Py times Qy is equal to your budget constraint. Why? Because X is 0. Okay. So that point there is Py times Qy, and that point is Px times Qx is your budget constraints. Okay. All good with that. You're happy with that so far. So therefore, this position there and that position there is exactly the same. So that position and that position. So this position you have Py over Qy is equal to your budget surplus, your budget constraint. Why do I put an S? It should be a C, but anyway, let's keep on with the S. And at that point, it's also Py over Qy is equal to your budget constraint. So both of those two, okay, is that specific value. So what we can do is we can convert this to say, because remember it's quantity, so that's quantity is equal to budget surplus divided by Py. And that point there is also, I'm running out of space now, is also Qy is equal to the budget surplus over Py. I'm going to redo this again. Let's just rather do it here. Okay, so it's a little bit less cluttered. Okay, so let's quickly draw this. There's my budget constraint. Okay, so that point there, okay, remember this is quantities. And remember we're going to take this formula. So that point there, okay, that point there, Qy is equal to my budget constraint divided by the price of Y. That's that point there. That's 0. And this point here is Qx is equal to the budget constraint divided by the price of X. Okay, so I hope that makes sense. And that's just derived from our basic formula here. Because if there's 0 on the x-axis, that's 0. On the y-axis, that's 0. And because it's quantities, I'm just restating it into a quantity format. Okay. So therefore, remember, the slope, what is the slope? The change of x, a change of y over a change of x. So that's a change of y over a change of x. So that means this is a change of budget surplus over a change of price of y over a change of budget surplus over a change of the price of x. All happy with that? Okay, because remember, what is a change in y? Because remember, that's going to be the same equation as that. Will be exactly the same. So that's what I'm saying. It's a change in budget surplus, etc. And change in x. That's exactly the same. Now, what's a change in the budget surplus? Change in the budget surplus is equal to 0 because it's constant. Okay, for both. Okay. So what we can say, therefore, is change in budget surplus over a change in the price of y. And I'm just going to say that's going to be divided by, okay, and that's going to be divided by a change in budget surplus divided by a change in the price of x, or equals to change in the budget surplus over a change in the price of y multiplied by change in the price of x over a change in the price of the budget surplus. Okay, and we know that's 0 because it is a change in the budget surplus is 0. Okay, so we know that's 0 and we know that's 0. Okay, so therefore, this basically becomes, therefore, that's 0 and 0, so you multiply, that becomes change in the price of x over a change in the price of y. Okay, we also know that the prices stays the same. And therefore we can say that the slope is really the price of x over the price of y. We've showed that now to be the case through this set of formulas and calculations. Okay. So hopefully that makes sense. So now you can see how we are deriving the slope of my budget constraint, which is really the relative prices of x and y. Okay. So therefore, save this before the thing bombs out again. Let's insert new slide. Come on. I hate it when I struggle to do this. Anyway, so let's copy this. Paste. Keep on running out of slides. And paste. Okay, so let's save it. Let's quickly go for the pen again. So therefore, go back to my curves. There's x, y, and x. That's 0. There's my budget constraint. There's my slope of the budget constraint. And we know that the slope of the budget constraint is the price of x over the price of y. And we've showed you why this is indeed the case for this set of calculations. Okay, so I hope that makes sense. Deriving the budget constraint, the slope of the budget constraint is equal to that thing. Now, what we further know is that if I draw another one here, of y and x and 0, and we draw indifference curve, then we know that consumer equilibrium occurs. Oops, sorry. Now let's see if hopefully it doesn't shut down. Okay, now I need to draw it. See if I can draw it nicely. It's difficult. There we go. It's not looking good. I want to draw it. So it just saves it. It just becomes a tangent. Okay. So let's say this point. That's the best I can do. Sorry, but that's the best I can do. With these bloody pens. Anyway, so what we're saying is that this point here is where this specific individual is in equilibrium. So this specific person is equilibrium here, where the marginal rate of substitution x for y is equal to the price of x over the price of y. Now, what do I say? Because remember, the slope of the indifference curve is the marginal rate of substitution, and the slope of the budget constraint, as we showed, is the price of x over price of y. So where they touch, they share exactly the same slope. So at that point, the slope of the indifference curve is exactly the same as the slope of the budget constraint. And therefore, the marginal rate of substitution, which is the budget constraint after the indifference curve, must be equal to the price of x over the price of y. That makes sense. So therefore, at consumer equilibrium, now I need to draw this again. I don't like this. There we go. Oh, that's a good one. That's a brilliant one. I like that one. So that's y, and that's x and 0. That's the indifference curve, and that's the budget constraint. Okay. So at that point, let's make it clear. At that point, there's a number of things that happen. We know that the marginal rate of substitution x for y is equal to, okay, change in y. Oh, well, let's put it differently. Let's not use the change. Let's use d. Is the d, come on, dy over dx. We also know at that point marginal rate of substitution x for y is equal to the marginal utility of x over the marginal utility of y. We also know that at that point the budget surplus is equal to the price of x over the price of y. And we know that at that point the marginal rate of substitution is equal to the budget constraint. Therefore, there's three things that's equal to one another, and that is dy over dx is equal to the marginal utility of x over the marginal utility of y is equal to the price of x over the price of y. So those three things are equal at this specific point. Okay. Hope that makes sense. And we showed it using all, oops. Ooh, you see, this is the thing. Because read only, save as. I don't know why it does this. Ooh, let's save it as number 2. I don't know why it's doing this. Hopefully. Oof, you see, it's unstable. It's gonna, just see it's saving. So it's not that there's an issue with my OneDrive. It's gonna bomb out, I can tell you now. I don't know why see, it doesn't want to save. So what I need to rather now just do, let's see if I can, sorry for that. I don't know why why it's so unstable. So let me okay, so let's rather than don't save. And let's restart it. Let's see till what point. Okay, so now it's okay, so let's see. Okay, I can't paste it in because okay. Anyway, so that's it. I hope you can still remember now that there's a whole lot of things, but in essence, what it boils down to, and I don't know, that's why I need to keep on saving because this damn PowerPoint of mine just keeps on crashing. But anyway, at this point, we have dy over dx is equal to marginal utility of x over marginal utility of y is equal to the price of x over the price of y. Okay. So all of those things are happening here. All of those things are happening here. So in general, we're not too phased about this. We don't really deal with this. Is what we're going to focus on. So in this case, we're going to say my marginal utility of x over the marginal utility of y is equal to the price of x over the price of y. We can restate this into my marginal utility of x over the price of x is equal to the marginal utility of y over the price of y. So we can work in either format. It's exactly the same thing. We're just restating it a little bit different. Okay, so that's important because let's draw our Edgeworth box diagram. So let's see if we can copy it. No, it's too busy already. So let's rather draw. I want to work with this one because it's already done. But now I have to do, let's see. Okay, no. Let's rather do a new one. So let's draw our Edgeworth box diagram. There we go. There's person A, there's person B. And let's say, okay, that's cokes and haircuts. And that's cokes and haircuts. So let's draw a position of general equilibrium. Okay, so let's draw a position of general equilibrium. For person A, let's do it this way. There's person A, general equilibrium position. And there's person's B, general equilibrium position. Okay. That general equilibrium position is this point there. Okay. So that point, there's a whole lot of things that's happening there. There's a whole lot of things that's happening there. Because they are tangent, it means the marginal rate of substitution x, y for person A is exactly the same as the marginal rate of substitution x, y for person B, which is also equal to the budget constraints because they share now budget constraint. The budget constraints are exactly the same, okay, because it's a tangent. Remember, they're both now on the same budget constraint. So in that case, the prices for x and the prices for y for person A is also equal to the prices of relative prices of x and the prices of y for person B. So therefore, the relative price relationship between A and B is also exactly the same. also exactly the same at this specific point. So therefore, this point, the marginal utility of x over the marginal utility of y for person A is equal to the marginal utility of x over the marginal utility of y for B is equal to the price of x over the price of y for A is equal to the price of x over the price of y for B. So you can see there's a whole lot of things that's happening at that specific point there, that general equilibrium point. All these things are true. Okay, so you can see there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 variables that is in equilibrium. And if any of these variables change, then it will upset this equilibrium position. So if the relative price of y for person B changes, it will influence all of this. It will have to run through this whole time until we get to another steady state. So let me just, oops, come on. I need to keep on saving. Otherwise, if it bombs out, then I have to start all over again. So saving is what I need to keep in mind. So let's just take this one. Let's see if I can copy. Let me rather just rewrite it. I don't like to rewrite it, but let's rather rewrite it. So the marginal utility of x over the marginal utility of y for person A is equal to the marginal utility of x over the marginal utility of y for person B. So this pens are terrible. Over the price of x over the price of y for A equals to the price of x over the price of y for B. Okay. So if any of these things changes, and remember marginal utility is change in total utility, marginal utility is equal to change in total utility. I'm not going to write it down. Okay, so let's rather see if I, oops, there we go. Luckily I've saved it. That's why I'm saying this, my PowerPoint is terrible. It's going to shut down now. Yep, it's going to restart. I shouldn't have lost too much. Yep. Let's delete it. Anyway, I shouldn't spend too much time deleting these things. Okay. Now it's deleted half of the stuff. Jeez, my God. Anyway, let's keep on. Marginal utility of y and marginal utility of y for person B. Okay, so there we go. Or what we can do is we can rewrite this. Okay, because remember, we have this as well. Ne? We have this as well. So we can say that the marginal utility x over the price of x for person A is equal to the marginal utility of x over the price of x for person B is equal to the marginal utility of y over the price of y for A is equal to the marginal utility of y over the price of y for person B. So all those things are also true at that specific point. That's why I said, and I keep on saying, at that general equilibrium point, there's a whole lot of things that is in equilibrium. And that's why it's called general equilibrium, because you see all these things must be true because they share a single slope. Okay, so therefore the slope, and we know all sorts of things when we take them as individual parts, and now we just add them together. And therefore we get all of these things. And as you can see, if any of these things changes, then it leads to a whole chain reaction. So for example, if price of X for person A increase, then this is no longer in balance. And therefore, this will influence a ripple effect on all of these sort of things. So if this becomes now bigger than that, then this needs to rebalance. If this needs to be rebalanced, that needs to be rebalanced. And this needs to be rebalanced until we get to another steady state. Okay, so that's what's happened in the market now. There's a set of changes that is now being put in motion with a change in one thing. So by changing a particular variable, it leads to a set of it leads to a motion of other. What's a nice way of stating it now? For the life of me, I can't. It sets off. Anyway, I hope you understand what I'm saying. Is if one thing changes, it sets off a chain. There we go, a chain reaction, and that leads to all these changes, and ultimately it must rebalance to a next steady state. So we'll go from a general equilibrium position. Let's say there's a shock, or there's a change in attitude, or a change in behavior, or whatever the case might be. That leads to a particular change, and that sets off a chain reaction that filters now through the whole economy until. And that set of reactions will continue until we find a new general equilibrium position. Okay. And as I said, so the economy is in fact the whole time searching for this general equilibrium position. Okay. It actually never, and that's why we call it a dynamic. The economy is always dynamic. It's not stable. It's not static. Static means that being in general equilibrium, this position is the norm. It's not the exception. And I think that it's evident that cannot be true because there's millions and millions of things that happen every single day that influence this steady state. So therefore, the economy per definition can never be static. It always is dynamic in search of this general equilibrium position. Yeah, but anyway, this is a general. You can add now for person C, person D, person F. So this becomes an equation for millions and millions of people. So you can understand why we limit it only to two persons. But you can just add on now, etc., etc. So this is steady state. This is general equilibrium position. That is what happens at that specific position. And I said we've simplified to explain to you or to show you why this actually is the case. And I said now we can move, or now we can expand it to include as many products, as many services, as many people as you want, but you can see that it becomes quite a mission. But that's what modern computers, general equilibrium, maths and all these things are all about. Anyway, so this is the point that I wanted to make, is that this is the golden equation. This, let me put it this way. This is the golden equation. That's the one that we're going to work with. That's the one that you need to understand and keep in mind when we deal with general equilibrium. Okay, so at this specific position, remember when we were here, at that specific position, position F, that situation, we were not in general equilibrium. That position was not true. So because this is not true, there's possibility for trade. And because there's trade, these things continuously shifted and changed. This set of activities until we get to a position of G. Okay, so that's the initial position, which suggests that we're not at general equilibrium, because, and it could be that that might be bigger than that, or whatever the case might be. Okay, but we don't have a general equilibrium position. It's out of balance. The economy is out of balance, out of sync. And therefore, there's a set of motion of activities that's starting to take place that runs through this economy, for buying and selling, for exchange, for trade, until we get to point G, where this position is indeed the case, until we reach general equilibrium. Okay, so that is the important part. That's the point where we are in a static state. But I said the static state is generally not the norm. It's the exception to the norm. And the economy, if it's a market-based economy, is continuously in search of this position. But it never actually reaches this position, because there's always some change to these things. What else did I wanted to go through? I think that is it for now. In our next video, let's start playing with some examples and apply these calculations and illustrations, and so some real world life examples to see how we can apply this and how we implement these for the maths and for the graphical interpretation. So that's going to happen in the next video tutorial. But for now, we've covered the basics. We've shown you the steady state. We've shown you the general equilibrium condition, and the Edgeworth box diagram, how it works, etc., etc. Okay, so hopefully you guys are still following and are making sense. I'm not just dabbling and rabbling around. I'm actually making some sense. So if there's anything missing, just please let me know. If there's something I did wrong or whatever, just let me know and we'll fix it. Otherwise, I'll see you in the next video. Look out for that. Look forward to hosting you again. Please like and subscribe, share, and I'll see you on the other side.